Neeraj, we are live. Please go ahead.
Thank you so much, Harish. So, good evening, ladies and gentlemen, our friends from across the nation. Myself, Neeraj Arora, I would like to welcome you all to this wonderful webinar session on water management through passive strategies and sustainable urbanization. So, friends, this session is being jointly organized by ASSOCHAM GEM Rajasthan chapter and West Bengal chapter. And the supporting associations are Ministry of Environment, Forest and Climate Change, National Book Trust for this Conclave EXPO Awards. So, friends, as you all know that ASSOCHAM GEM Green Building Council is organizing a virtual awards on 3rd and 4th. So, this 3rd and 4th session is physical. So, friends, for this wonderful topic, we have a galaxy of speakers with us, starting with the architect Devatosh Sahuji, Chairman ASSOCHAM GEM West Bengal chapter and Principal Architect and Partner eSpace. Welcome, Devatosh ji. We have with us architect Tushar Sogani, Chairman ASSOCHAM GEM Rajasthan chapter Private Limited. Welcome, sir. We have Professor Modi, Department of Water Resources Engineering, University Kolkata. Welcome, sir. We have Ms. Neelam Manjunath ji, CEO, Founder and Managing Trustee, Center for Green Building Materials Technology. Welcome, madam. We have with us Mr. Akash Yadav, Country Manager, SAARC Countries, Scan Group. Welcome, Mr. Yadav. We have with us Mr. Gaurav Agarwal, Architect Gaurav Agarwal, Co-Chairman, ASSOCHAM GEM Rajasthan Chapter, and Principal Architect Gaurav Agarwal Design Studio. Welcome, Gaurav ji. And we have Architect Sonia Gupta ji with us, Honorary Secretary, ASSOCHAM GEM West Bengal Chapter, and Principal, MIT School of Architecture and Planning. So I'll not take much time and would request Architect Devatosh Sahu ji for the welcome address. Over to you, Devatosh ji.
Yeah, namaskar and good evening everybody. Distinguished speaker, Professor Ashish Majumdar, distinguished speaker, architect Neelam Manjunath, and my dear friend, architect Tushar Sogani, Neeraj ji, Mr. Neeraj Arora, who is the head of Green Building Certification of the Green Building Council of ASSOCHAM GEM. We have Honorable Mr. Architect Sonia Gupta, who is the principal of Amity School of Architecture and Planning, and who is the Joint Honorary Secretary of ASSOCHAM GEM West Bengal. My dear Gaurav Agarwal, Mr. Akash Yadav ji, who is the Country Manager, SAARC Countries, Khan Group, and those who are with us right now in our virtual session. I welcome you all to this fantastic fourth virtual session of our GEM 4th International Sustainability Conclave. This is jointly organized by Rajasthan chapter and West Bengal chapter, and we are very happy and honored to have all these distinguished speakers who will be sharing their thoughts and which will be used for the future of our country, future of the nation.
And I have my.
I will just point out. I want to point out 3-4 points, which will probably help all of us to understand the grave situation we are going through. The United Nations World Water Development Report says nearly 6 billion people will suffer from clean water scarcity by 2050. And this is the result of the increasing demand of the clean water, reduction of the water resources, and increasing pollution, and obviously the economic growth. It is suggested that this number, what we have just mentioned, it may be underestimation But actually, the scarcity of this clean water in 2050 may be much more than what we are thinking now. Now, coming to the Indian context, the water scarcity in India is an ongoing water crisis that affects nearly 1 million people each year. And India, you'll be surprised to know that India has only 4% of the world fresh water, but it supports and sustains the whopping 17.7% of the world population. And this is unbelievable, probably, and we don't know how India is sustaining that. The third point I want to mention that India is the world's biggest groundwater user. The continued exploitation of the groundwater caused the groundwater level in India to decrease by 61%. And this figure is as per the Central Groundwater Board. The fourth point I want to mention here is according to the Central Groundwater Commission, they say that the climate change is obviously affecting our climate and the pattern of the rainfall. But the rainfall, what we have already, it is more than sufficient to cater this 1 million people. But it is a sorry figure that we Indians are only able to use the 8% of the rainwater because of the poor rainwater harvesting systems and the policy. And another thing is this urbanization. And urbanization is happening in a phenomenal speed, and probably it will be happening, but there should be some policy. I think it is a policy-less urbanization which is happening in India. And that's why, in this context, the topic which was chosen for today's discussion, that is the water management through passive strategies and sustainable urbanization, is probably the apt subject for discussion today. We have a galaxy of speakers who will be sharing their views, and we are looking forward for their views and presentations. Thank you so much for the patient hearing. Over to Nirajji. Welcome, Manjunathji.
Yeah, thank you so much, Debatoshji. Thank you so much. Now I would request Architect Tushar Sogani ji, Chairman ASSOCHAM GEM Rajasthan chapter, for the address. Over to you, sir.
Yeah, thank you, Neeraj. Can I have the presenters right? Yeah. Is my screen visible?
Yes.
Okay.
Yes, sir.
Let me make it full screen. Yeah. So very good evening to this fourth virtual session by ASSOCHAM GEM in collaboration with the Rajasthan and West Bengal chapter. At the outset, I would like to really welcome Architect Debatosh Sahu, who is the chairman for West Bengal chapter, his secretary from West Bengal, Architect Sonia Gupta, Architect Gaurav Agarwal, Mr. Ajay Popat, Mr. Akash Yadav, and today we have got two stalwarts from the industry, Professor Assis Majumdar, who's from Jadavpur University. So I welcome you, sir. We are going to have a lot of takeaways through your lectures, and I would like to welcome Ms. Neelam Manjunath, who is again a stalwart from the industry. You know, ma'am, we are going to have a lot of learning from your lectures and presentation. So, friends, before when this topic was, me and Debatosh together worked out this topic, that what should we talk about? I think it was the most heavy mentioned app topic in the present scenario: water management through passive design strategies and sustainable urbanization. Now, let us understand that what exactly is water management. Water management, the definition of water management, it includes the activity and the action which is required to stop the pollution of water bodies, to prevent the natural disaster, and allows for more efficient use of water resources. As you all know, that water is a very vulnerable resource, and therefore its protection is extremely important. And we need to have water management because we have got limited water consumption with us. We need to maximize the use of sustainable water sources, and there should always be a cost-effective water infrastructure. And why is water management so important? It is important because, out of 3% of Earth's water is fresh water, and out of that, only 1.2% can be used as drinking water. And rest is locked up in the glaciers, ice caps, and buried deep in the ground. And water is emerging as #1 global concern in terms of development. And the world will face a 40% shortfall between the forecasted demand and the available supply of water by the year 2030. Very alarming for us. And that's why I think it's very important for us to really think in terms of water management. And when we think in terms of water management, I think the first thing which comes to mind is that it should be through passive strategies, which is going to last for a longer period of time. And by year 2050, there will be an 80% increase in water demand in the cities. And the development, the urbanization in the cities is going to create a lot of impact. Demand for the food will also increase by 50 to 60% due to an increase in the global population. And this is the statistics which says that out of world's 500 largest city, 19% are predicted to have conflict with the rural area over water. Very alarming for us. And I think it's a high time that we should really think about the management of water. And what is water sustainability? What sustainable water management means the ability to meet the water needs of the present without compromising the ability of the future generation to do so. And whenever we talk of a building, there's always a natural cycle of water. And in building, the water comes from the various sources. It comes from the rain, it comes from the reuse of the water, and finally we keep the water. And our intention should be that we should give this water back to the Mother Earth from where we have got. This is a cycle of water which we need to work upon. And the most important thing is, how to save water. Very, very important for us. Because if we not conserve water, as I told you that in the times to come, by 2050, we'll have a very alarming situation. We need to, don't waste our water on the plants. We need to grow the native plants that actually becomes water free after a certain period of time. We should use water cans instead of water hose or sprinklers, which actually creates a lot of water wastage. We should install water efficient water system. There are a lot of ways to save water, which we have been always talking about. And I think in my speaker is going to talk about that. And most important thing is that we should understand, we should make it very simple, that what are the simplest 10 ways of conserving water. We need to install low flow plumbing fixtures that we always talk about, that these are the fixtures which actually consume less waters. We need to use the grey water for irrigation. We should know how to replace water intensive plants. We should install rain sensors on irrigation. We should insulate the piping to reduce the heat loss. We should talk about to avoid the leak detection and the repair. We should think in terms of monitor cooling tower water chemistry, and we should try to reduce water pressure. We should try to harvest rainwater. We should educate the water users. I think in today's seminar, we got stalwart as Professor Assis Majumdar and Neelam Manjunath is going to talk about. So I think it's a high time that we should listen to them, and we should really work on the water management with the passive measures and try to conserve water, which is a threat to us. So I think without wasting much of time, I would like to invite Professor Assis Majumdar, who is from Department of Water Resources Engineering, Jadavpur University, Kolkata. So Professor Majumdar, we'd really like to hear from you. Over to you, sir.
Thank you. Namaskar. At the outset, I would like to thank the organizer for inviting me to this very useful event, I must say, which will be really which deals with a very, very important topic. And obviously, since I am in the field of water resources engineering, it is very close to my heart. And so I think it is quite appropriate topic that we have chosen today. And before I start, I would like to Sri Neeraj Arora ji, architect Devotos Shahu ji, architect Tushar Sugani, architect Gaurav Agarwal, Madam Neelam ji, Professor Sonia Gupta ji, and Sri Akash Yadav ji, and many I might have missed one or two. Please kindly help me, kindly don't forgive me about it. And then let me go to before going to the topic, one thing I'd like to say is that today, whatever I would like to discuss, what I have thought of is that very recently, we are facing with a problem. We are facing with a problem of, this urban flood. So I have thought that why not we should take some of, the urban flooding, as such, as one of the topic, and rainwater harvesting and that sort of measures, which we should take up. And so accordingly, just try to highlight some of the issues, some of the points related to urban flooding, as well as rainwater harvesting. The first thing I would like to really try to rather draw your attention that if you go by the Sustainable Development Goal, SDG, the 11, then you will find that it calls for inclusive, safe, resilient, and sustainable cities. Now, obviously, as you know, a new city, if we design, we can do it in a way, but a city like where I am staying, that city itself is 300 years old and has been developed by its own course of development. And so a lot of things which we cannot change now, we can try to only help some of the modifications that we can bring about, which can do certain betterment of the present situation. Like India, since, with the challenges we'd like to, highlight is mainly in the urban flood management. And this is a problem we are facing, particularly in this year, to the greatest extent. I got a call from many of my urban friends, planners and, managers of the different housing complexes, that they are totally under waterlogged condition, even for more than 10 days. So this time, they are facing it. Earlier occasions also they might have faced, but once the incident is over, people used to forget, and then again when the problem comes, a lot of hue and cry takes. And so urban flood management, one of the possible solution is rainwater harvesting, which I'd like to touch upon, but there are a lot of things to be taken into consideration while we are designing the storm drainage, even in a new housing complex. Emerging pollutant threat is one of the very, very important issues nowadays, but I am not going to discuss all these things because time is very less, but just only one or two points about it I would like to touch upon. Emerging pollutants are those pollutants, particularly which are coming from the pesticides, as well as our personal care products. Now, these personal care products, nowadays in a city, there is a rampant use of it. Everybody are using it. And from that, whatever the, wastewater is carrying, ultimately that leads to, this our river system here, even in Kolkata, it is the Gangetic River or our Gangetic River basin. We are really getting this sort of pollutants to a great extent nowadays. But why it is emerging? Because it is a very critical, already has been taken care of by the many of the regulations by the developed countries. So for the European developing countries are concerned, developed countries are concerned. But in our case, we have not even till now we have not make any sort of regulations about the emerging pollutant. If you go by the water norms, whether it is by the Bureau of Indian Standard or even it is by the regulatory boards, other regulatory boards, you will find that these issues are not there. These sort of parameters, what should be its limit, that are not taken care of. But they are disturbing our human health to a great extent. There are even our endocrine system will be totally, totally disturbed if we take it for a long period of time. So removal of emerging pollutant is a great challenge to the water treatment designers. So these are also one of the things, how we can utilize our natural treatment system there is another issue.
Click on the slide. Yeah.
Yeah. Now, in our urban flood problem, this is one of the real pictures of our urban flood this year itself in a very, sophisticated area, so far you call, but we are facing that problem this year also. And if you go by this, it is nothing new. We have to face this. Why? One thing we should keep in our mind that there is a, whenever we design something, we have to limit our boundary parameters to an extent that we have to face certain, because actually whenever we are designing something, we cannot take risk as zero. There is always a risk, because whenever there is a precipitation, there are chances of another precipitation with higher intensity of rainfall. Now, you see, these are the different incidents that took place from 2000 and including this year, where in the many metro cities of our country, we are facing the severe problem. So one of the flooding, major aspects I would like to say, that is whenever we develop a city, the impervious surface cover increases to a great extent, and which increase in runoff volume and flow velocities. And our time of concentration is at any point of rainfall to the point of discharge, that is where we are allowing the water to the canal or to a discharge point. So these time of concentration becoming less and less when it is it's a surface, the paved surface is concrete, we have a very less time to reach there. So the problem is becoming more and more, because if I get time for the water to flow, then obviously the management becoming more easier. Now the subsurface drainage network capacity also is limited. The limited means, with the time, it sometimes, it is getting choked. I am showing a figure just below. If you have a look on it, you'll find that almost this is where, man-made sware in Kolkata area, one of the South Calcutta area, where you will find we have visited that place during that point of time. KMC have invited me, and later on they have jacketed it with a GRP lining. Now we see when we remove it, they remove it, we find that almost more than 80 to 90% is totally blocked with the deposition. So these are the another factors. Now, if we see the urban factors, one is our global climate change. Already at the introduction, the speaker has already mentioned that we are having a change in weather pattern, and most importantly, that we are now receiving high intensity of rainfall for a short period of time, and that is causing the flash flood, and that is causing the difficulty of regulating the flow. How we can regulate the flow, how we can regulate the control the drainage, that is another problem. So to drain it out, we need some time. So we need certain way that, first of all, it should not be very high, intensity should not be very high, but at the same time, it should give us some more time to get it, distributed over time. And that is very, very important. And now you see in urbanization, all of us know what are the problems that due to the developments, that is what is taking place everywhere in a city. Improper and inadequate drainage system is an indirect, cofactor which can cause the urban flood. And improper or no solid waste management is prevailing, basically. And that's why, everything is getting discharged or getting thrown to that, we are throwing everything on the canals, ultimately, which is blocking our grid chambers, and ultimately it reduces the navigability of the carrier of the canals and our khal, whatever you call. Now you see the root cause. There are certain urban flood key questions. First is the root causes for flooding in urban areas. That already I have touched upon one or two issues. Urban planning issues is another thing. When we are planning, we should have to consider what is the slope of that particular catchment area. What is the natural way the drainage took place earlier to the development. And as you know, in Kolkata, I am giving you very good examples. We have towards east, we have a slope. And the East Kolkata has been developed very recently, and there is a very big expressway sort of road is there, which we call EM bypass. Now that bypass is causing now a divide between the other side, between the two sides of our Kolkata city. And so the natural slope is already blocked, and we are to lift the water. And we have a very nice natural drainage system through the East Kolkata wetlands, now which is also nowadays still working, but having threats of getting silted over a long period of time. Desiltation is very important, although some of the desiltation work took place very recently for the last 5-6 years, and there is a little bit of improvement. Climate change impacts and adaptation issues, risk-based planning process, and GIS environment, land use planning and governance, multi-hazard risk assessment, forecasting and warning time and system that needs to develop, and risk undertaking, mitigation and monitoring. Now, before that, what is the guidelines now we should consider? One of the very important guideline in this respect is the NDMA, that is the National Disaster Management Authority 2010, which has certain guidelines for management of urban flooding. And there, if you go by this, one of the very important suggestion is that there must be a local network of automatic rainfall gauges. for real-time monitoring with a density of 1 in every 4 square kilometer in all our 2,325 class 1, class 2, and class 3 cities. So it's a, it is very, I must say, very important guidelines, but I do not know when we will be able to achieve it. Probably at this moment, I am telling you, in Kolkata, we have only, particularly which are basically monitored by the IMD, Indian Meteorological Department, are the two. If you take up not the extended Kolkata, but the so-called Kolkata city. So I'm not considering the extended part of it. Now, if you consider that there are only two, and if you see only the strategic expansion of Doppler weather radar network, that even in Kolkata, I am telling you, there is one, and in our country, that is whatever what we should live, that it's a long way to go, but we are to achieve this target. Establishing of urban flood early warning system. Still, it's much more planning is needed for that. But however, this is one of the guidelines, one of the important guidelines, I must say. And there is another thing is obviously, which I have mentioned, GIS platform. But another thing which is very, very important is the contour mapping, which is at the 0.2 to 0.5 meter contour interval, which is very, very important, I am telling you, because the thing, whenever we develop any housing complex, urban complex, what we do is that we take our, jurisdictions like that whatever land we do hold, we are taking that as a catchment, but that is never a catchment. Catchment means where all the rainfall, what is falling on that particular area, that is flowing through a particular guided system, and obviously it could be a drainage canals, it could be a number of drainage canals, might be some of the tributaries. Ultimate, there should be an outlet point. So these should be our natural boundary. So whenever we consider that our housing complex is a catchment, we are not following the natural guidelines. Automatically, the water will come from the other part of that natural catchment to your particular complex, and you are to take care of properly. Otherwise, there will be water logging, as we are experiencing all the time, so far the Kolkata, many housing complexes are concerned. And now the future storm water drainage, if you go by that, that should have a runoff coefficient is 0.95. You can understand how fast this is taking place. Earlier, it was really less. Now it is 0.95 of the C value. Whenever we find out by rational formula, discharge is dependent on that particular runoff coefficient, and which is 0.95 here. So you can understand that what amount of water is coming. And then we can divide the total flood in urban areas into three types: type A, type B, and type C. Type A is the localized flooding caused by inadequate drainage of stormwater, whereas type B flooding, events occur less frequently than type A floods, and particularly the impacts include temporary disruption to transportation system, which is many a times we are experiences in the most of the metro cities of our country. And there is a large type C, which is a large scale inundation causing widespread disruption and damage. And nowadays, even type C is taking place to a great extent. So these are the different policy statements starting from 1954 till National Water Policy of 2002. You will find a different development, different suggestions, guidelines has come. So far the flood problems in India is concerned. But now our national water policy addressed many of such issues. The area identified as flood prone have been used for parks and playground. One of the suggestions that we can take care of is that which is as flood and prone area that we can do for a parks and playground, which can tolerate occasional flooding, because these can use as a temporary storage of the water. And this sort of, even the local ponding, in many of the, I am not, kindly excuse me, my architect friends, I know it very well that sometimes it is needed for the development. You might have to go for, some of the natural water body. You have to keep nowadays whenever there is, some sort of development take place, but we should try to keep as it is, whatever there is some water bodies, because these act as an impounding reservoir for the, minimizing the peak of the urban flood. Now, the buildings and bridges should be elevated, protected with flood walls and levees, or designed to withstand the temporary inundation. The drainage system should expand it to increase their capacity for detaining and conveying high stream flows, as well as, for example, use of rooftops to store water. Techniques to promote
Ashish ji,
yeah.
sir, I'm sorry, but we are running short of time.
Out of time,
So
yeah.
please, if you can complete in some time. Yeah.
Okay.
Thank you so much, sir.
Okay,
Thank you.
surely, I'm trying to do that. I'm just trying to, one or two things that I'd like to discuss that is very, very important. That any rainfall event, if you consider, the frequency or return period of a storm event is very, very important, which can be defined as the average recurrence interval between two events, successful events, equal to or exceeding a specified magnitude. Thus, it is stated that the return period of rainfall of 20 centimeters, just for an example, in 24 hours is 10 years at a certain station A. It implies that on an average rainfall magnitude equal to or greater than 20 centimeters in 24 hours occur once in 10 years. Just I'd like to mention in Kolkata city, the Britishers who have designed it, they have done it for 6 centimeters of rainfall. So 6 centimeters of rainfall and the frequency of rainfall, that is 2 times a day. So if it occurs, obviously the design drainage system can take care of. But if it exceeds the value of 6 centimeter rainfall, or if it exceeds by more than 2 times, there is obvious that there will be a waterlogging. That we need to understand. In Kolkata particularly, there is another problem is there, since we have Ganges, where we are discharging our storm water. That the problem is that whenever there is a tide in the, because our part of Ganga, that is, when they are reaching to Bay of Bengal, that we called Hooghly, and during that stretches, there, what Kolkata city is by the side of Hooghly River, and there is a, high tide, then there is a high rise of the water level in Ganges, and you cannot just discharge it there. So your system again is dependent on another factor apart from rainfall, intensity of rainfall, duration of rainfall. Another factor, particularly for Kolkata city, but for other city where there is not a tidal river, then there is not a problem like that. But however, this is one of the very, very important, and we have to try the different type of distribution. That is the basic equation, and this is the graph I would like to really discuss. This is what you can, it is an important manual of stormwater drainage system. This is CPHEEO manual, and 2019 Government of India has published this document. It's very important. You see, just get an idea. If a storm took place in a 5-year, once in a 5-year, that means this much of magnitude takes place once in a 5-year. Like, let me say, if the intensity of millimeter of rainfall is 60, then you can say approximately 28 minutes of duration you can expect. But whenever you are trying to do something with a duration less than 15 minutes, then you might have a 100 millimeter of per hour of rainfall. So these, you just try to understand whenever I am designing something, I have to design it for 30 years of data, and I am to take certain frequency of occurrence of the rainfall. Like it should be once in a 5-year or once in a 10-year, or it's more than that. So more than that means if I want to get in a more and more safer position or safer condition, the problem is that your pipe, your drainage system design will be too much to take consideration all this into account. So one of the very important thing I'd like to touch upon is the rainwater harvesting, and these are the very good guidelines nowadays. But the rainwater harvesting should be done to the aquifer where from the water is exploited. That means water is withdrawn. We should recharge it to that extent only, and our recharging should have a basic filtration initially to get rid of the basic impurities and the problems. And later on, obviously, through the layer, it automatically gets, filtered. Now, the construction and installation, South City Tower, which I did means I have designed it in the year of 2007 and 8. Then this is the first time, and we recharged it, and we have seen, even I have tested it after its installation after a long time, and I found that whatever design rate I have calculated, and artificially I make the rainfall like this, triggering the water there, and I got a very good response rather than more than what I designed. So these are the different things that we can do here. Just another example, in a Damdam area of our Calcutta city, there is one of the housing complex. I should not mention its name. It is getting in a Bagjola canal, which is one of the very important canal of Kolkata. You see, if we do the rainwater harvesting, we can, at least during the very heavy point of time when there is heavy rainfall, we can have a 3,600 cubic meter of harvested rainwater. We can halt it for some time, and we can also recharge it to the house. So you see, this could help, and ultimately when we'll allow this water will only give a better input to the Bagjuna canal as a better water, and which can reduce the pollution load or help to assimilate the pollution load of the canal. So that's why I am telling you, it helps the environment also. So this is what I would like to share with you all, and thank you very much for giving me some additional time that I took, to complete my deliberation. Thank you very much, sir.
Thank you, Professor Assis Mojumdar. That was the real insight of the water management in terms of urban flooding. I'd just like you to cite a condition in the city of Jaipur in the year 1981, when actually our walled city, which was planned in the year 1726 by then architect Vidyadhar Bhattacharya, so he was not a qualified architect. And when the Jaipur faced the average, rainfall in Jaipur in July and August is almost 180, 190 mm, but that time it was 500. And you will believe, sir, that the way in which the drainage system was planned in the year 1726, nothing happened to the walled city, but the outer city of the Jaipur was devastated like anything. So I think this was the thing that our ancestors have actually planned the water management through passive measures. We architects, we designers, we engineers really need to learn. And I think so whatever you mentioned, that how to overcome the urban flood, and manage water is a point of concern where we are thriving. We will not wait. Can't wait for the condition what has happened in the Cape Town in 5 years way back. We don't want this in any part of the world. So I think we should definitely thrust upon all this thing. I think Professor Assis Mojumdar, we're short of time, would have listened to you more, but time didn't permit us. Thank you so very much. It was a nice insight. Now, let us help me welcome another stalwart from the industry, Mrs. Neelam Manjunath, who is the CEO and founder of Managing Trustee for Center for Green Building Materials and Technology. Ma'am, all our spectators and viewers, are desperate to listen from you. Over to you, ma'am. Thank you.
Thank you, Tushar. So good evening to everyone. I think since we are running short of time, I straight away will share my presentation. it was a very good presentation by Professor Assis. I think. Have I been given the permission to share? Have I been? Okay.
Yes, ma'am.
Yeah, now it's done. Okay.
In the meantime, you can put your questions to Assis Mojumdar in the chat box. Gaurav can put these questions to Assis Mojumdar, sir. All the viewers can put their questions in the chat box.
Okay, so another a little different aspect of water management, and I'm talking on behalf of an NGO today. I'm donning a different hat, though I'm an architect, and I have been practicing rainwater harvesting ever since I started practicing 1991. So I'll be just running through because since I've been doing it for such a very long time, and I was trying to tell my clients how to do and why to do and things like that, and there were certain problems that I faced, and that's when I thought it will be I have to have a different kind of approach. So through my trust NGO, Center for Green Building Materials and Technology, we have taken some approach. So I'll quickly run you through that, which is also about creating sustainable rainwater harvesting enterprises and green jobs. This I think we all are aware, so I will not go in detail. Now, urbanization is one factor, which is what is urbanization actually? So it's a human settlement where we have a high population density and infrastructure of built environment. And they are created through, again, a process called urbanization, are categorized by urban morphology as cities, towns. Now, whenever any kind of development actually happens, we do it happens at the cost of environment. We have to do it like that. I mean, that has been somehow, and probably because of that, for a long time, the millennium goals were separate and the environmental goals were separate. I mean, there were two different things which later got combined to become the Sustainable Development Goals. So, however, for a favorable environment for human capital development, which is being called as economy, we also need development, that simultaneously to be done. Now, the Population Division of the United Nations Department of Social and Economic Affairs at the time predicted that the urban population would grow at 6.4 billion by 2050, and I think 37% of that growth will come from three countries: China, India, and Nigeria. We are in the part of the world where we have the housing deficit, and there are different kinds of housing deficits. One is that we don't consider the houses done by the environment-friendly so-called mud and bamboo and local wood as houses, and so they are considered as non-houses, and all the others, are considered as housing. So that is another problem that we have, and especially in the cities, we have that pigeonhole kind of a construction, which is called development most of the time, and that is done. The construction sector, as we know, is a major contributor to global economy and also to the global warming. And why it is so? So any country's development is measured in terms of the amount of concrete poured in a particular year, and that's the kind of we have reached a situation where these are the kind of definitions of development rather than human development or human development index. This is what, and human development index is generally again taken as how much of concrete was poured to provide them infrastructure. So this is the thing of development that has happened, and that's little, as we know, is quite lopsided. From the construction sector, we do more than 43% of fossil fuel combustion. But when it comes to green building, which we generally talk about, and we have been talking about, and urbanization also, it's just 5.7%. So that's the kind of gap that we have. And this is a little bit of data on water extraction and the building industry in a report which is released by Down to Earth. The world extracts approximately 145 cubic kilometers of water every year, and the building construction industry is one of the one sector which consumes a substantially high amount of water every year. For every 1 square meter of wall construction, an average of 350 liters of water actually gets consumed. So that's the kind of data that you have, and the quality of water for construction are same as the drinking water. And this is to ensure that the water is reasonably free from such impurities such as suspended solids and organic matter and dissolved salts, which may adversely affect the properties of concrete, which is the sign of development, and especially the setting, hardening, strength, and durability, and all these kind of things. And the water usage, which happens, if you can see on the right side, the pie chart, the building construction, then you have automotive, electronics, and others that we have here. The need for water in construction are of different types, and it can be water supply may be readily available in some locations, other places it is inaccessible. So given that water plays such an important role in many on-site processes, where can site managers turn to if they have a limited supply or no supply or on-site? Bringing an alternative temporary water supply will ensure that you can deliver those key services. The top users of water for construction sites also are in drinking water, supplying on-site facilities, and I will not run through. I mean, it's already there on the screen. Watering, grouting, curing, drilling, and piling, landscaping, pond filling, all this dust suppression, all these things happen. I will try to talk in the context of Bangalore, and again take it to all the cities that I would be talking about. If we, thanks to all the so-called development that we have in Bangalore, the IT city and the Silicon Valley, we will be touching 2 crores population shortly, and we have an IT sector with millions and millions of concrete and glass buildings built with high energy guzzling materials. And very recently, we have been told that there's a design district coming of something like a Dubai thing happening in Bangalore. That's another. When ITPL started, we saw sudden change in Bangalore. Now we have another one that is supposed to be coming. We do, we make the city water energy secure. How do you? While providing the basic needs of housing, food, electricity, and water. This is a kind of wastewater treated daily in Bangalore. And this is the kind of treated water that goes to Kola Fields, which is close by, for the factories. And this is the kind of 50,000 to 70,000 liters water required to build a house on 1,000 square feet. So that's the kind of, thing that is there. And how much water we actually need? This is another thing which we actually need to look at. 135 liters of water per person per day. Out of that, only 5 to 6 liters or maximum 10 liters is to be of potable quality. The rest of the water is used for washing and bathing. So if you see in this kind of a pyramid, there's a water demand, which is a basic water demand, and then you have a reasonable water demand, which can be flexible, and there's a luxury water demand, when we talk about this kind of a thing. And this is something which you really need to take care that we don't, get into this kind of a problem. And how do we actually solve this, that we are able to supply that critical 10 liters of potable water, and all the other water can be actually treated water and other water, which can be used for the other purposes. And how do we actually go about it? If you really have the breakdown, water usage breakdown in domestic water usage inside, this is the kind of usage that we have for WC taps and the washing machine and the hand washing, as you can see. And the efficiency of each one of them also matters. How much efficient we are supposed to be doing it. And the commercial water use breakdown, if you can see, catering, hand basins, urinals, WC. And again, in the efficiency measures, how efficient are we in generally actually doing that? So in the kind of WC, some work has been done in trying to where maximum water goes, but all the other areas, not really much has been done probably, and that also needs some kind of a thing. Now, if we are building some buildings for simple living, because I really always talk and try to see the measure from the basic living. How do you design spaces and buildings to fulfill the basic needs of a shelter to perform various activities, be it an office or a house? And what should we do actually, if I just, list it down just like that? Use materials with low energy, water management on site, rainwater harvesting, all these kind of things. I think other people have also spoken. Natural landscaping, and decentralize the supply of water and electricity. I think this is another factor which is very, very important. Today, I'll be concentrating only on rainwater harvesting. I will not take much. Now, there's one thing that I don't know how many people are aware about this. What is the source of water on this earth? The only source of water on this earth is rainwater. Whether be it, you call it river, you call it pond, you call it anywhere. And the water only comes from the rain. So the only water source in the world is from the sky, and we have to catch it where it falls. It's as simple as that. There's one more, startling figure that we have as per Central Water Commission. India gets 4,000 billion cubic meters of rain every year, whereas we need only 3,000 cubic meters of water every year. So what actually happens? Why are we still short, of all this kind of, where the problem actually lies? And this is by 2030, the demand for water in India will be twice as much as the supply. This is the kind of figure that we have. And according to the Composite Water Management Index released by Niti Aayog, this is going to be twice of what we actually have, right now. And that will be the water for hundreds of millions of people. The potential of rainwater, if I talk about Bangalore, the kind of thing that we have is a very simple diagram that I have shown. I will not go into detail of technical thing because technical lot of data is available. You have diagrams available, but still, why it is not really happening and why it is not working? We have in Bangalore, this is Solar City annual rainfall. This is the kind of rainfall that we have. If your roof is around 2,000 square feet, you can collect 180,000 liters of water a year in Bangalore, and you can actually live off the grid of water, come very, very comfortably. I've been living for last 13 years. Even if you collect half of that, even then, you're quite well off. And rainwater potential of the city, Bangalore city, is around 1.1 billion liters per day, which is like, the potential we have to harvest. What was is 1.1 billion liters, where the potential is 16 billion. And this could put an end to our water problems. That's why, again, and we have a lot of rainwater harvesting management systems. And when we talk about systems, immediately everyone talks about a lot of, paraphernalia of technical gadgets and things like that. Let's talk about, I think just now we had, the example of Jaipur and example of Rajasthan. We have such good water management systems that were available there, and then groundwater recharge and all water bodies, all these things are there. They were already there. And this rainwater tanks that we are doing today was what was there earlier. We have closed them, and so we have to do them. We just cannot fight nature. You have to live by that. So this, if we are doing these kind of things, the level of the water management systems, this will enable water availability for farmers in the villages and agriculture in the rural urban areas, and also without having to pump large amounts of water and put the land under stress. Limitation, I will not go in too much in detail. What are the problems? The lack of awareness in sustainable way of saving water, the lack of quality rainwater harvesting installation systems, the dearth of good people, servicing professionals. I have a rainwater harvest system. I am doing it, but still there are some problems. I never get a person to service it properly, though I have been trying to promote it for such a long time. Traditional skills of craftsmen who are digging wells and make ponds have become redundant in urban setup. That's another problem. And there are a lot of skill sets that are required to do this. Planning skills, good craftsmanship, design engineering, entrepreneurial skills. But one of the basic things which I think I have not put in here is, in Bangalore, I will tell you, we get water from Mysore. It is pumped all the way from there at 97 rupees per kiloliter, and it is provided to the citizens at 7 rupees or 9 rupees per kiloliter. Why would anyone do rainwater harvesting? You tell me. Because the kind of for doing rainwater harvesting, you are given some kind of subsidy, which is like 200, 300 rupees in a month or something like that. Whereas you already are given so much of subsidy from 97 to 9 rupees. Why would one do? That's another policy issue, which could be solved by giving people the potable water at a at that kind of a rate, maybe 7 rupees or 9 rupees, which is absolutely essential, or even free. But over and above that, the demand that we talked about as the demand, which is not the basic demand, over that the rate of water actually should be increasing exponentially, and that's where we probably will be able to do that. That's one thing. And we don't have, I said, enterprises are not there in the rainwater harvesting sector. You keep looking for them, you don't get good people, you don't get servicing people. It's very, very difficult to maintain. So people have, because it's mandatory for the plan sanction, so they build a rainwater harvesting system, but 95% of the time it will be defunct. And that is something which really needs to be again taken care. From our CGBMT that we have been doing, last year we did a lot of seminars, which we got all simple talks. We had Rajendra Prasad Singh, we had so many other 4-5 people and who talked about. We had Mr. A.R. Shivkumar, the rain man of Karnataka. we had Mr. Vishwanathan, the Zen Rain Man. We had all these people. We brought them on one platform through CGBMT to talk about this, to create awareness, that we did last year. And then this year we are starting a basic course of about 40 hours, 20 hours and 20 hours, to let people know as to what is actually rainwater harvesting and how we should be doing it. And then we have an advanced course, and we have a hands-on training that we are doing, and we are incubation and enterprise development. And this is something which we are trying to do, that because you want to be sustainable, you want to do something, but you don't get the the skilled people to do that work, or people who are enterprises who will be supplying you these kind of things. And this is another very big the supply side of it is, which is really a problem. So demand is by advocacy that you can do, and then you create the supply chain through all these kind of things. And this could actually and then further details, if we go up, we can tie up, we can have social enterprises. And we have an August gathering today. We would be most happy to network with organizations, even architectural associations, even engineering people, universities, NGOs, and government. We will be most happy to collaborate with all of you to scale up this kind of a thing that we have started. It's in a very nascent stage, but we have already started the work, and we would be like, and also we would like to have some business linkages for our people who will be incubating through us, so that they can actually form this self-sustaining enterprise development can be done. And what is unique about our approach is that we are not just always talking and telling that, okay, government should do it, or that person should do it. We are telling people that you should be doing it, and you should say that I will do it. And that's what actually needs to be done. So we are trying to address this issue from demand and supply side both, and taking into consideration the 3 P's that we talk about: profit, the economy, people, and the planet. And we have the green jobs, we have all these things, and then we have in people recognition of prior learning, the earlier people who have been kicked out of the profession because of all this centralization of water supply. If you decentralize, people will become, the day water starts not coming from the tap, people will take ownership of what they have to do and how they have to get water. Things will definitely become better. So this and this whole thing also will go to biodiversity restoration, minimizing the waste, water waste and pollution, and recharging the groundwater. There's one more very important factor I would quickly want to discuss. Just to not discuss, just tell, is that there's something about this town planning, and I do not know how many. And since we are talking about urban design, is every land has a holding capacity. How much population it should be able to hold, and for that, what percentage of it should be left free and without any kind of a development. And if that is taken care, I think this lot of urban flooding that Professor Ashish talked about, it's like you get water, you don't use that water, you let that water to flow, that creates flood, you get scarcity of water. I mean, how stupid can anyone actually get? I mean, if you really try to analyze the whole situation, it feels very absurd that we have more water, and we are not, but we have scarcity on one hand, and we are doing flooding, and that also in urban areas, which should not have happened. So that is something which actually really needs to be looked at. And these are like we have been doing, and we have experts from the MSME sector, we have academicians, and we have all the people. This is our panel team, which we have been working on the water security thing. We have Dr. Yellappa Reddy. He's a very big environmentalist. Dr. Shobha Anand Reddy, she's a water conservation expert. Rainman, Mr. A.R. Shivkumar. Sangeeta Agasti, which is MSME consultant for Foundation for MSC, and now she is from INBAR. She's a country manager. And we have Miss Kanmani. She's an architect and volunteer working with us from this one in developing the course and all the things that we are actually doing in rainwater harvesting. And this is the progress so far. We have been doing in all our buildings. We have provided consultancy services for almost that kind of, if you can, 20 million square feet, where we have totally harvested so much of water. We have done 5 webinars, we have done advocacy programs, and we have also done courseware. We also have been doing a lot of lake rejuvenation, getting into Bangalore's lake rejuvenation groups. And we are the warden for one of the lakes also here. We also, worked with environment support group to form a guideline for Bangalore's future, how we are going to take it forward. And in that, in the water security panel, we were there and we actually gave a solution to that. This is the photograph that, this is the sketch that you see here. This lake called as Raju Kaluways, how they feed the lakes and how do you actually try to see that there's no urban flooding in the kind of thing. Now, we also, this is a lake program that we did in 2008, along with the citizens and along with the people, trying to tell them, and we called it Walk for Water. And this was the program done by us, our rejuvenation, and we have the lecture, Bangalore Climate 20, that's what the ESG program that I was talking about. And for all these our services, we have been recognized thanks to people like you all who have recognized our efforts, and that really gives us the strength to keep going forward. And our strategy is to establish a circular water economy, that is PESTEL framework that we talk about: political, economic, environmental, legal factors. Create demand by IDA principle, which we like attend. You get the attention, generate interest, generate desire, and then the action, how you actually go about it. To build sustainable organization through micro, which is direct, meso, which is capacity building of the people, and supply chain, and macro analysis, which is developing ecosystems, hold stakeholders to create agile supply chain. We also want to have this kind of using sustainability enablers, which is IoT, impact investment, management commitment, infrastructure, and government policies. We would like to take cognizance of them and develop credible impact analysis and measurement tools for frameworks. Like I said, 3P, P and the SRI, SDGs, ESG compliant, environment, and environment support and governance. And we have compliant organizations through Resolve framework. And servitization model for RWS. I think that's very, very important. You don't sell rainwater harvesting equipment, you sell service, so that it all gets taken care. The way it is done for many. I mean, if I have to just give one example, is like the we have the Boeing, which doesn't sell the the motor, it sells the service per hour. If we have to have that kind of servitization model, I think our things will be taken care of. And we are working on an app and to take this forward. This is like these are our partners who have been with us: the Dalbag Institute, Education Institute, Karnataka State for Science, International Science, Mahatma Gandhi World Institute, Rafaj, Abdul Kalam Technical University, Lucknow, and many other. This is my last slide. I just give one was for electricity, so I will not go in that. If each person in Bangalore saves 10 liters of water per day or use less that much. So 10 into 2 crores people in Bangalore, 20 crores liter water saved per day. This is a very simple, achievable goal by collaboration of architects and the common man through better design and management of precious resources. Absolutely doable. And one last word, I'm sitting here in a panel of, when we're talking about urban design, de-urbanize big time. That is one of the biggest solution to most of our climate change problems that we have to mitigate. De-urbanize, ruralize. Thank you so much.
Thank you, Neelamji. Thank you so much, and really, very, very interesting, very knowledgeable presentation, I must say. So I would appreciate the presentation of Professor Ashish Majumdarji and Neelamji. I can't explain you that the WhatsApp messages I am receiving. Everybody is asking for the presentation of yours and Ashishji and appreciating the presentation. So thank you so much for the wonderful presentation, Ashishji and Neelamji. Now we will move forward and would request Harish to please run a small video on water management by one of our partners. Harish, please do the needful, and then I will request Akash ji for his talk, sir. Harish, please do. Thank you. Now I would request Mr. Akash Yadav, Country Manager, SAARC Countries, CAN Group, for the presentation, for the talk. Over to you, sir.
Thank you, Mr. Neeraj. Thank you very much. Good evening to everyone, to all participants and my fellow speakers. Today, the topic is very interactive, and I think we should all focus on this, especially this topic of water management. We are always talking about this subject. We are thinking about this subject, but I think now it is time to do a big reaction and make some good actions so that it can be followed, and we will get rid of the problems which can come out in the coming future. Okay, so everyone know when we look at the ocean and just thinking that we have an infinite water resources, but we do not have the infinite water resources. According to the UN, 1.2 billion people, about 1/5 of the world's population, live in areas of water scarcity. This is an incredible concern for the future. If I talk about water stress by country, then India comes in extremely high stress figures, that is almost 80%. So this is happening because we are not using our resources in an adequate manner and keep the things going as they are. Still, we are not using efficient technologies for harvesting and collecting water, I should say. About 37.5 million, approximately 37.5 million billion, that is 16 zeros almost, of gallons of water vapor is in the atmosphere at any one time. Yes. If all that vapor condensed at once, Earth would be covered by about 1 inch of water. So this is an idea of abundance rather than scarcity, which we looked at. So how does mankind look at this technology? How do we harness technology to do better with what we have? We use these technologies, what we have, but sometimes it antiquated and they have negative feedback. For example, oil, fossil fuels, which we extract, and then we put that into CO2 emissions again. So that interesting thing is that we have, if we look at our troposphere, and we can find that there is more water in the atmosphere, which is present as a vapor as compared to all the rivers. This is something which we often don't look at. And this is a matter of concern for all of us. We all learned to protect water resources after we faced droughts, we faced bushfires, we faced flooding, and now COVID. In terms of resilience in the built environment in particular, is that the design of buildings has a huge part to play in the way that cities operate. With regards to being resilient to changes in the environment, we know that buildings changes in the environment can reduce consumption and minimize impact that cities operate in a system of lots and lots of small pieces all fitting together. So we should look at how each building can better perform. So I want to highlight 3 more points. For example, what is sustainable water management, the urban water cycle, and the critical role of building design. Sustainable water management means using water in a way that meets current ecological, social, and economic needs without compromising the ability to meet those needs in the future. These are basic concepts, example, water efficient appliances that are required under building and planning regulations. But you can go further and use higher technologies, water efficient appliances, than those of whole field around behavior. How people use water appliances? Do people switch off the tap? Do people switch the tap off while brushing their teeth or while taking shower, etc.? Not really. From a design point of view, the way we design influences the water a lot. If there is a lot of lawn area, for example, in a warm climate, and we are using a lot of water, so some basic design features will impact on how much water is used. So key area for us is around harvesting rainwater, and you can do that at a minimal level and have a rainwater tank, or you can be more sophisticated about it, run a wall design system, which we can use to flush toilets and to do clothes washing, etc. That makes a very, very big difference. Other point is recycling is a big issue. There are much more high-tech solutions that use some of those less polluted wastewaters, treating them and feeding them, uh, and then feeding them back into the cycle, either at a house level or at a municipal level. And then I suppose the most interesting area at a building scale is water-sensitive urban design. Managing the buildings and landscapes so that they are retaining the water that falls on them, using that water efficiently and reducing negative impacts on the surrounding environment. For example, the traditional urban water management, which was being followed by England in 1800s. So the water was coming, and then they're using it as a treatment plant. They're taking in water from the reservoirs or as resources, natural resources. So then they're treating in a treatment plant, and then it is going to the city. Again, then it is going to the sewage treatment plant, and then again it is going to the ocean. So that was been followed. Right now, in these current scenarios, what we are using we are using water from our natural resources. Then we are treating the water. We are going to the buildings or the houses, and it is directly going to the ocean. We are not using it to the sewage treatment plants. So that is again all the hazardous water and non-usable water is going to the ocean, which is very, very difficult for upcoming future, that kind of practice. Further, I would like to just recall everyone, for example, in the forest, if I take an example, or of urban area, if any rain is happening or rain is there, then 80% of the rainfall, it is going down to the ground again. But in terms of urban areas, like 80% of the rainfall, it is going into the sewage directly. Only the 20% is usable for, I should say, for rainwater harvesting, or we are using for a different applications. Better buildings for sustainable water management, where I should also make a light on that subject, that buildings can use resources more efficiently with technologies to reduce water and energy use at source. For example, we can put the insulation on the buildings to avoid the heating and cooling systems and save our resources. And ultimately, the water is also being managed to do that. Then another point is buildings can generate renewable energy and water by connecting to natural systems through sunshine or rainfall. So we can save solar electricity, and also we can save water using, again, rainwater harvesting. Third thing in building segments is that buildings can change their processes so that rather than generating a waste, they create inputs to a different process. For example, recycling wastewater and using for irrigation, for example. Scarcity of water and drought at the same time it's flooding somewhere. So we can manage water in such a way so that we can avoid those issues. We can also add water storage tank as much as we can do it in the commercial buildings, and can give in good architectural aesthetics too, which nobody is doing it, and in maximum people are not thinking about that factor. For residential buildings, we can also use rainwater harvesting, and that can be used for flushing, laundry, which led to reduce the demand of the main water supply. For example, in lots of the projects which have been done in foreign entities, like Queen's University is a very big example in Belfast and Northern Ireland, London Townhouse in United Kingdom, then Merrick Valley Library in Australia. And then I think, of course, in India, there are many big projects which are working on especially on rainwater harvesting and making bigger tanks so that the roof area or the underground area can be utilized, and we can avoid using dependent only on the main water supply. Further, I want to add one thing is wastewater management solutions are basically commercial treatment plants, or we can use domestic treatment plants. Fuel and oil separators can be used. And the rainwater harvesting solutions would be fully integrated below ground systems and above ground system storage tanks. So these are my point of views to manage the water using urbanizations, which can protect us for making our good future. So that's it from my side today, which I want to highlight a few points. And of course, we should always focus on water, and it should be done not with a one person. Everyone, every single person in the world should focus on this subject and this matter. Then only we can save water for upcoming future. Thank you to everyone.
Definitely. Thank you so much. Really very informative message you have given. Thank you so much, Akash ji.
Thank you very much.
So now I would invite Gaurav Agrawal ji, Co-Chairman ASSOCHAM GEM Rajasthan Chapter and Principal Architect Gaurav Agrawal Design Studio for the question answer session. Over to you, Gaurav ji.
So much, Neeraj bhai. It was indeed a wonderful session from all the three speakers which we have. I personally thank Neelam ma'am, Professor Assis, and Mr. Akash Yadav for that. We have many questions lined up into our question answer box. So I'll take the first question with Professor Assis Majumdar. Sir, are you there? Professor Majumdar, sir?
Assis ji, please unmute yourself.
Never mind. I'll take this question to Neelam ma'am first. Neelam ma'am, see, you have mentioned that 135 liters per person per day is what the requirement is. And moreover, out of that, only 10 liters of water is actually the potable water which we need. The rest of the water goes into cooking or flushing or other purposes for that matter. So we have a question which is very relevant to your context, and moreover, you have also mentioned that the water to Bangalore is being brought from Mysore, and it has 97 rupees kiloliters and something. Some figures were there. So a question is from Vasant Kumar ji, is that water is elixir of life, but people dislike treated water, and that is basically an apprehension, I must say. Even I too have an apprehension. So why can't we make water supply authorities to supply free clean water only for drinking and cooking purpose for probably some limited hours a day, and rest of the water can be brought from a different pipeline, and we can meter it and we can do it like pay as you use it. So will it be possible, and does that actually check on the wastage of water which we do with the portable treated water which is coming from the corporation? Madam, you have to unmute yourself.
Is the question to me? Yeah, I
Yes,
have
ma'am.
unmuted. Yeah. So, and that's what I said, that it should be segregated. So what is the question actually? I said that it should be segregated.
Yeah.
I mean,
So a policy
can be even
framework.
free, because almost being given as free. Yeah.
Exactly. So the point is the voice is to be raised to the authorities that we can have a dual piping system, maybe one piping for only potable water,
Yes.
which is for limited time, and another water can be the metered
Yeah.
water, because you exploit water, you overuse the water, then you pay for it. So
Yes.
so purposely, this can be a motto in future, which you can do, right, ma'am? No?
Yeah. So one more thing which can be done is that this drinking water supply, suppose we have to do through the corporation, we can do that. And every developer or all other these other areas where we have these people. So if you do rainwater harvesting properly in a building which is managed by the cooperative society or something like that, or a group of people, that is utilized, and that is again treated water. I mean, that can be a bigger source of also water, because then because water is not created by anybody. The water that we have today was from the time creation happened on this earth. So it is the same water which is actually going on. So nobody can create water out of nothing. So this is something which is also, because if we do a lot of harvesting of water, as we also know that even from example from Rajasthan, even with such minimum amount of rainwater, they have been able to have they used to have the supply of 2 years supply used to be there in in these cities where you have this Jaipur and other Rajasthan, other areas with such less rainfall. Then why it cannot be done in all other areas as well? So the harvesting thing is something which is also together with that. So I know it's not always that you put everything on the corporation doesn't work, and then there are a lot of problems in things like that. So people also had citizen active things also can actually work together with the corporation, which I feel, and it should be like what do you say, a collaborative effort, because government cannot do everything. That's not really possible.
Yeah,
It's not
true, man.
so
True that.
we all have to put our hands together and do it.
Yeah, true that. Okay. Neeraj, I believe that Professor Assis
Did I miss something?
is moving somewhere. No,
Yeah.
ma'am. Thank you. I think he's moving to some other location.
But I think he is listening to us. Ashish ji, if we can hear from you.
Right. So I've just put up a question to Professor Assis, and whenever he gets time, he can just put the answer in the chat box. Assis,
Yes.
sir, will that work fine? Majumdar sir, I can't hear you. Is that fine with you?
I think we can move to Akash ji. I mean,
Yeah.
yeah.
So my next question is to Akash ji. Akash ji, I've been listening to you, and I can understand that you have a vast idea of the overseas part of it. And in the country like Dubai or in the Middle East, they are these days treating up or desalinating the water, the sea water, and they are making it a potable water. So my question to you, see, we are talking about rainwater harvesting since years and decades. Now, do you really feel that this is the right time? And when India is such a country which has a vast coastline, so is it not the right time that we should start investing in setting up the plants for desalination of seawater and the transport system from the coastal states to the states which are landlocked? Maybe probably like putting up a plant in Gujarat and supplying Rajasthan through it, putting up a plant in Maharashtra and supplying Madhya Pradesh through it. So is it not the right time that we should even move to that aspect as well?
Yeah, thanks for this question. I think you're somewhere right, but as everyone knows, like also you said, ocean comprises 97% of the Earth's water by volume, and almost 71% of the planet's surface. But if we look for the bigger picture on the planet, there is like 97% of the salt water, and that leaves 3% of the water in which 1.5 is frozen, and rest is potentially fresh water. That means less than 1% of water which is actually drinkable. And coming to the point which you mentioned, like we can put the desalination plants basically in the west region in India, if we talk about. Of course, I think government is planning to do that, and they are already doing as well, but of course might be on a very, very low scale. But I think in my point, there are various, apart from only the desalination part, there are various more options. Like maybe if you heard about the sky water works. For example, we can use warm air, yes, and then put in a air filter, and then put a that air filter is hidden in the cold surface or condensed, and then that can make a mimic clouds. And then we collect that in a water collection tank, and then it's going to the carbon filter, and then we can drink the water. So this sky water can also work and giving a solution in different regions instead of just putting a desalination plant in some areas and then transporting, because we are 130 crores. Yes, it's very difficult to in terms of transporting it. I think second option also there is other way, instead of taking water from long distances like dams or reservoirs, or even though from desalination plant or pumping water, etc. We can also make water pumps in that is atmospheric water generators. So in that you take a biomass and put in the for example biogasifiers, and then they take an intake of air, and then it is going to filter it again, and using the gravity is putting a water down, and then you can get a portable drinking water. So that is also which we call atmospheric water generators. And normally it's also, in my opinion, there is more phenomena. For example, but biomass is intaking the carbon dioxide, and then we put inside and then take extract of carbon dioxide again. But in the bioproduct like biochar and biochar goes into the soil and becomes nutrient. So that is in a sustainable way that we are extracting carbon dioxide and again putting in the soil back. And I think there is one more popular method, which is carbon negative technology. You can get a biomass with a biochar sequestration. For example, getting it from like I just explained. Yes, we're taking a carbon dioxide and putting again in the soil, and in that. Or the best option, in my opinion, is atmospheric water generators, which we are not doing. But yes, in for example, countries like United States, they're using it in not in a big scale, but they started using since now 7 years. And they have put lots of plants, and you can put this atmospheric water generator in a shipping containers, for example, and they take those shipping containers in different cities, and we can get the water very easily. So that is like kind of portable water generators. So that is of course very good innovative idea of doing that.
Yeah, thank you, Akashji, for that insight. Uh, I being an architect, I'm not that so technical, and it was quite a technical thing. But surely I'll also search it out, and probably this seems to be, or this sounds to be, quite a win-win situation.
Yeah, it's an
Neeraj, I
innovative
believe that
idea
you,
of doing that. Yes,
yeah,
so it's quite easy, but of course the government has to put a bit of more focus on that. And of course we are Indians, we are everywhere, so we can do that. It's not a big that much of big technology to use it.
true that, true that. Neeraj, I believe that's almost quarter to seven. Uh, I think we'll take this question and answer, and we'll send personally to the panelists, to the speakers, probably by mail, and we get an answer through it. Neeraj,
Yes, Gauravji. Yeah.
I
So,
think it's over to you.
yeah. So, and I would request Ashish ji and
Questions
Neelam ji.
for being disconnected for a, yeah, I was disconnected for a little bit of time. I'm
Oh,
very sorry.
Majumdar sir, never mind. We'll mail you the questions which are specifically for you, and we would love to get an answer from you sometime when it is comfortable with you, sir. That's all, Neeraj ji, from my side.
yeah. Thank you, Gauravji. And I would request Ashish ji and Neelam ji to share the presentation if possible, because lots of delegates are requesting for the presentation. So we would request you to share your presentation with us on the email IDs. I'll request Sonia ji and others to to contact you for the presentation. And before moving to
Forwarded it
architects,
to you.
yeah, we have received. So thank you so much. And before moving to architect Sonia Gupta, we will share just a very small presentation from our partners, and then we'll request Sonia ji to extend the vote of thanks. Yeah, Harish, please do the needful. That's really wonderful. So now I would request Architect Sonia Gupta for the vote of thanks. Sonia Gupta ji is the Honorary Secretary, ASSOCHAM GEM West Bengal Chapter, and Principal, MET School of Architecture and Planning. So Sonia ji, over to you.
Thank you. Am I audible?
Yes, perfect.
Yes, thank you so much, Neeraj, for giving me this opportunity to thank. This is the most pleasant task of thanking everybody who made this program to this evening's program so wonderful. Let me begin with thanking our speakers, Architect Neelam Manjunath and Professor Ashish Mojumdar, who not only made brilliant presentations about myriad issues faced in water management, but also offered solutions that we can proactively implement. Architect Neelam Manjunath, I would, from my heart, thank you for telling us with complete certainty about the pigeonhole development, the alarming figures for water extraction by the building industry. And thank you so much for showing us how simple living or basic living can put in place the immense potential of rainwater harvesting. And of course, you are doing such brilliant work on advocacy, on rainwater harvesting systems, networking, business linkages, use of technology. And could I thank you enough for the final slide on how we should de-urbanize? Professor Ashish Mojumdar, thank you for bringing our attention to urban floods and management and the emerging pollutant threat that actually jeopardizes human health itself. Yes, we do know about the rising impervious surfaces, but thank you for telling us about the national water policy, about using flood-prone areas as parks, and most importantly, a rainfall analysis to comprehend the issue. Mr. Akash Yadav, thank you so much for bringing in the figures and statistics for water stress and presence of water in the most unexpected of places. The critical role of building design and service systems for water sensitivity. Thank you so much. Now, please allow me to thank Neeraj Arora, Neeraj ji, for being the wind under the wings of this GEM ASSOCHAM movement. Mr. Pankaj Dharkar, who isn't here today, who is the chairman, of course, of ASSOCHAM GEM Green Building Council, who has always given us leadership from the front. Thank you, Architect Debutu Shahu, for your welcome address, where you brought to us the overview of the dire situation we are in with respect to freshwater availability. Moderator, Architect Tushar Sogani, thank you for bringing in water management, the importance of water management, and also for bringing out the salient points so succinctly. Mr. Gaurav Agarwal, that was really a vibrant interactive session where you articulated all questions with absolute clarity. And I think I would be failing in my duty if I did not thank Harishji and Shubhaji for excellent coordination. All the participants who were so clued in to what was going on, the brilliant questions that came in, and of course, last but not the least, all our industry partners who have made not only made presentations here, but also made this wonderful program ever more successful. Thank you so much.
Thank you, Sonaji. Thank you for the vote of thanks. Harish, next slide, please.
Thank you so much, ma'am.
Before closing, I would like to extend my deep gratitude to the delegates as well, those who are attending to the session at this late evening. So thank you so much, delegates, for your continuous support and blessings to the ASSOCHAM GEM Green Building Council. And we would like to extend our thanks to Ministry of Environment, Forest and Climate Change, Ministry of Housing and Urban Affairs, Council of Architecture, NEREDCO, National Book Trust for the support. And thank you our partners, principal partners, platinum and gold partners for the support to the event, without which this event was never ever possible. So thank you so much once again. And friends, please join us tomorrow 11 a.m. for another wonderful session by Gujarat team. So tomorrow's session is on green rating system and smart cities. So this session is jointly being organized by ASSOCHAM GEM Uttar Pradesh, ASSOCHAM GEM Uttar Pradesh and Chhattisgarh chapters. So thank you so much. We will share the details with you for the registration. Thank you so much. Thank you once again. Harish, please